Right, so in this module, we're looking at an application actually really just an exercise of using arrays. But we're doing it in a context of something that actually is really important in computer science, and that is sorted lists or sorted arrays. So we're not going to really cover it in this course, but there's a whole bunch of algorithms for taking a list of numbers and putting them in order. And it's a pretty solid concept in computer science because it really demonstrates that there's a lot of ways of doing things. So there's many different ways or strategies for ordering a list of unordered numbers, and some are better than others. Some are faster than others. Some take up more space than others. Some work better when the list is almost in order as opposed to totally at random. And it's very illustrative of a lot of problems that don't have a lot to do with learning syntax, but actually figuring out what are the best strategies. Now, for this module, though, I'm not going to really look at taking a completely unordered list and sorting it. Instead, I'm going to look at maintaining a list of sorted values, and that's going to be a little bit different. It'll achieve a lot of the same end. So what if we wanted to sort the numbers that a user was going to type in? Let's say the user is going to type in any number of numbers, up to maybe 10 values. We could employ some of these search algorithms, and you may have heard them before: bubble sort, merge sort, quick sort. There's selection sort. There's several different algorithms, but one that I guess maybe doesn't really have a name is just to make sure that the list is never out of order. If we take the numbers from the user and insert them not always at the end of the array, which is essentially what we've been doing so far. We've always taken a value and added it to the end of an array. Instead of doing that, what we could do is put it into the array such that it is in the correct order. And each time the user types in a number, we're going to evaluate the array and figure out where to put this new number such that the array continues to be in order. So before we jump into how would we write code, let's just draw out a little bit of this concept so we can get an idea of what it's going to start to look like. So when we start off with an empty array, of course, there's nothing. Obviously the user is going to type in a value, and the first value that the user types in, and let me actually switch to a better color here. The first value that the user types in will always be the first value. So let's draw an array out here. Now, as the user begins typing in more numbers, let's say they type in number 5. So they've typed in 3, then they're typing in 5. What we would do is, instead of blindly just going to this location and adding the 5 here, which is ultimately what we were going to do anyway, we would start at the beginning and we would look to see whether or not this value was greater than or equal to 5. If it was, we would have to put the 5 in front of it, but it's not, so we continue. And as soon as we find an empty space, as soon as we get to the end of the list, we add the number no matter what. Now let's say the user types in the number 4. We're going to start at 3 and we're going to say, is this value 3 less than or greater than 4? If it is, continue. If it's not, if it's greater than 4, then we have to insert the 4 in front of it. We continue and we look at the 5. 4 is less than 5. The 5 is greater than 4. Okay? So if it is, now we have to do something else. What we need to do is we need to take this 5 and we need to shift it. We need to move it over here. And once that's there, we're going to overwrite the 4 and we're going to put it here. That shift operation is what we're going to worry about coding. Now, it's not quite as easy as that, because if the user types in the value 2, now we're going to look at this first value again. We're going to say, is 3 greater than 2? Yes, it is. So the 2 should go here. Now, if that's the case, we're going to have to take 5 and move it over, and 4 and move it over, and 3 and move it over. And we have to do this in the right order. All right, so let me switch to another color just to differentiate these operations. If I take the 3 and I push it over here, it'll overwrite the 4. If I write A1 equals A0, that'll take that and we'll get rid of the 4 and put 3 there. And then I lost the 4. So I don't want to do that first. What I'm actually going to have to do is start over here. I'm going to take this 5 and I'm going to move it over. So I'm going to write something like A3 equals A2. Take whatever's in A2 and move it into A3. Then I'm going to take A2 and I'm going to fill it in with whatever's in A1. Take the 4, put it in there. Then I'm going to take A1 and copy whatever's in A0. There is the 3. And then finally, I'm going to say A0 equals 2. So to keep the array in order, what I'm going to have to do, and let me start from, well, let me stay here first. But what I'm going to have to do is actually 2 operations. I'm going to have to scan across the array and find out which index, which element is that number going to be in. If I scan across and I find a number that's smaller than the number that I'm adding, or if I find a number that's greater than the number that I'm adding, then I know that that number needs to go there, and I have to shift everything to the right. If I go through and I never find a number that is greater than the value I'm adding, then I know that that number is the biggest number, and I have to put it at the end of the list. So let's walk through this one more case, and let's think about trying to generalize some of the code too. So I'm going to start out with my array, and I'm going to start out with sort of an already pre-populated somewhat array. 0, 1, 2, 3, 4, 5, 6. Let's say count is currently equal to 4. And I've got a couple of numbers in here, 21, 30, 45. Okay, so my count is 4. My list is in order, and now the user is going to type in 28. So this is the input. First step, scan to find index to insert. So I'm going to go through, and for every element, I'm going to check to see whether AI is greater than the input. So it's not, yes it is, right? AI, if I is 2, is greater than the input. 30 is greater than 28. So now I found that. Insert at the index that I found in step 1. What I'm going to do is I'm going to go all the way to the end of the array. I'm going to go to the last value in the array, and I'm going to copy. I'm going to say A4 equals A3. And I want to point out that it is not by accident that these numbers are the same. Count always represents where the next element is going to be filled in, right? So A4, it's A4 because the current count is 4. If I currently had 7 numbers, then I would have had all of these numbers filled in all the way to 6, and I would have put that new number in, or I would have shifted over. The first value here would have been 7. I then say A3 equals A2. And now just keep in mind the number that I found over here was 2, right? This is the index where I'm adding this value. It's 2, right? That index is 2. So I have A3 equals 2, and that's going to move this over. So far I've got 45 here, and I've got the 30. Now I'm done. I'm done with the moving, right? I've got 30 replicated. It's time to overwrite that. So the other thing that I point out, it's not an accident that the last number over here, the smallest number involved in this, is actually the index where we're moving the value. Or maybe probably easier to put here, this value is always the index plus 1. It's always the index we find plus 1. And then finally we have a at 2 equals 28. And then we have count plus plus, and that's of course pretty important. All right, so from that I want to start to devise a little bit of an algorithm here. This is going to be one separate unit. This is sort of an independent step. Find the index to insert. Right? That's a scan across using a for loop to find the location. If it's all the way out here, then it's a kind of an easy case. Over here, what I want to do is I want to replace these values, these rigid values, with something that could put into a for loop. So what if we did this? For int I equals count I greater than, so while I is greater than index, 3 is the last value, I minus minus, decrement from 4 to 3, and so on. Each time around that loop, I'll do I minus 1. I being this value, and it's always, of course, 1 less. So let's just make sure that that works. So if count was equal to, let's now say we're going to add in, so now count, of course, right, is 5, right, after that pound plus plus. And at the end, I would say a index equals input count plus plus. Okay. So now let's test that idea. So let's say we're going to now take my input value of 13. So first step, scan to find the index. I'm going to go through and I'm going to find that the first value, the first I value, where AI is greater than the input, is 21. So index now is 1. My count is 5. I don't have to rewrite the 5 here, but obviously it's going to be 6 afterwards. Let's map this out. Right, so I'm going to add in an index while int I equals count. Right, so it's right here. I is right here. I certainly is greater than the index. The index is 1. Right, I minus minus. AI equals a minus 1. AI minus 1. That's going to take 45 and put it here. I minus minus, so we're here. AI equals AI minus 1. We're going to take the 36, or 30, sorry, and we're going to move it there. A minus minus, or I minus minus, sorry. We're now going to take the next one. Oh, it looks like I didn't put the 28 there. So that was 28 before. So it's getting a little messy, sorry about that. 28. We're going to continue. Now I is 2. It's still greater than the index, so we're going to move the 21 over here. Okay. I minus minus, and we're here. So we got 21 here. So we got 7, 21, 21, 28, 30, 45. Now I is not greater than the index, which is 1. So we stop. We're here. A index, A1, equals the input, 13. Count plus plus, 6. Right? So we've got our general algorithm. It's a little messy now, but as we start to put it into code, it'll become a little bit more clear, hopefully. So I'm going to write a function to scan across and find the index, and I'm going to write a function to then insert at that index. And I'm going to do that in 2 separate distinct steps, and it'll be a little bit easier to think about. So to summarize that, I'll write a function that can insert a number x into an array given an index to insert into. That was sort of the second step. Each time the user enters a number, I'm going to determine what index the number should be inserted to. That was sort of step one before. And then I'm going to call the insertion function to insert the number to the list at the correct index. Okay, so I'm going to create an array, let's say a max size of 10, int count equals 0. I'm going to have a do while loop, while, we need to read in our value into input. While input is not equal to -1, and count is less than 10. I'm going to read in a value. And read it into input. If input is not equal to -1, I'm going to add in order. And in fact, rather than even doing that, I'm going to just write a function that does that. Right? I'm going to, rather than doing it right in here, I'll just create a function. So void add in order. It'll accept the array int a. It'll accept the current count, which will change, by the way, because it's going to insert something. So I'll do an ampersand there. And I guess we don't really need the current size, but we do need the input, right? So value. So again, that ampersand is important because inside add in order, if we go back over here, one of the things, this is going to be all of the add in order stuff. One of the things that's going to happen is count plus plus. Right? And so if I'm changing count plus plus, I certainly want to make sure that that's passed along. Now in add in order right now, I'll stub that out and not do anything. I do want to be able to print afterwards, so maybe I'll print out in order, see out in order for int I equals 0, I less than count I plus plus, see out a I. Okay, so certainly at this point, not a lot's going to be really happening here. Maybe one thing we could do is just to make the test a little bit more pertinent. Instead of adding an order, I'm just going to add like I've always added. Count plus plus equals value. Right, so add an order right now will do something, but not really the right thing. But that's okay. That makes progress. We can build it. We can run it. We can see it starting to work. It's very important when we're doing top-down design, like we're doing here, is to get something working so you can sort of get the feeling that the overall architecture, the overall outline makes some sense. So I'm going to add my values, 5, 6, 4, 3, and it'll just, whoops, it doesn't actually do that. Let's figure out why. Add in order didn't print anything out. Sounds to me like perhaps I didn't change, or perhaps one of my counts are not right here. Let's see. Well, looking up here, actually, I see my problem. I never called the function. That's obviously not going to work. Pass in a, pass in the count, pass in the value. Again, or input. I kind of mentioned it ahead of time and then accidentally proved my point. It's worth running the program, even if add in order is not really doing the right thing, because I caught the fact that I never even called it. Okay, and now we see it. Okay, so now I have some confidence that my main outline works. It does actually read the values in. It calls the right functions. It prints it out. It's just that add in order is really not doing its job. So first thing add in order's got to do is find the index where something's going to be added. So find index. To do that, I need to know how many items are in an array. I need to know the array. I need to know how many items are in the array. And I need to know what value I'm entering in. Find index should do the first part. It should scan to find an index where to insert. And notice there are a couple of different cases. It could be in the middle, but it could be all the way at the end. Like if I went to insert 50 now, I'd go all the way through. And that might be actually instructive. Let's make sure that our algorithm works for that. Let's say now the count is 7. Let's switch back over to another color. Let's say the count is 7, and I want to add 50. Well, now I'm going to scan all the way across, and the first value that I'm not going to find any values. Right? So my scan should have given me 6. This should have been the index where I'm going to add 50. Right? So if I put 6 as this index, 6 over here, my count is, my count is currently, wait a second, I think I got ahead of myself here. Oh, count was already, I kept it at 6. That's what it should have been. So count was 6, sorry. Count is 6. Int I equals 6. I greater than the index that I found, which is 6. Well, this for loop's not going to execute at all. Right? So I had 6 numbers in it, 0 through 5. I figured out through my scan that the number should go here. My for loop gets skipped. A6 equals 50. And I would be done. And I would then, of course, change this really to 7. So, in fact, find index can return that value, and then the rest of my functions should work correctly as well. All right, once I find that index, I want to add here, add at a particular index. I'm going to say add here, add to the array, the current count of the array, and the value, but also the index, where. And at that point, I'm done. Those are my 2 steps. Find the index, add it at the index. I'll write in my functions. Find index returns an index, which is always an integer. Int a. Of course, that's a constant, right? There's no change to that. My count, that's not going to change. And my value, that's of course not going to change either. For int I, I'm going to scan across. And if I find a value in my array, if ai is greater than the value I'm trying to add, then I know that the value I'm trying to add should go there. Return I. If it's not, I keep going, right? And so if ai is smaller than the value I'm trying to add, if I'm scanning across at the number 50, and 50 is bigger than all these things, which means ai is smaller than 50, I'm going to keep on going until I find that. And if I make it all the way through there, then I didn't find anything, and I know that that value is the largest. It should go in the last slot. Return count. So find index will return count. And just for good measure here, let's say we're adding value at index, because it might be nice to see that print out as we start to work with add here. Add here is a little bit more tricky. We've got, now it's not a const, because certainly it's going to change the array. So it's just int a, it's the value, or the count, sorry. Now remember, count is going to change. And let me write the value and the index here. I just want to point out that you notice that I have this ampersand for count for changing, because I know that the job of add in order is to actually change how many numbers are in the array, right? But as a side effect, the number of things in the array is going to certainly change. But notice it doesn't directly change it, right? But it calls add here, which is actually going to add at this particular index, and that really will directly change count. It's important that all of them are passed by reference, so we can kind of chain the whole thing through. When we send in count from main, we're passed by reference into here, and now we're going to pass that by reference into add here. And add here will actually manipulate the count. So you want to take some time and study that and make sure that you understand why I'm putting the pass by reference in each spot here. Now, the pass by reference, this is really just this stuff. Right? So I'm sorry, the add here is really just exactly what we wrote over here. So we're going to say for int I equals count I less than the index, or I greater than the index, I minus minus. It's one of those rare cases where it makes a lot of sense to have a non-standard for loop. Because we knew that what we had to do, we knew that the indexes that we were starting at, we knew the indexes that we're ending at, and we knew that we had to go in opposite direction. We couldn't go left to right because we would just propagate the 13 over and over again. So we had to go right to left. Rarely, but not too rarely, we do need to write non-standard for loops, and you should try to make sure that you're comfortable with that. AI equals AI minus 1. That's it. That's all we need to do. At the end, we say A at the index equals the value that we're adding, and we do count plus plus. And again, pass by reference will carry us through. We build that, we run it, we'll see how everything's going to go here. Now notice I actually, because of that adding there, that's kind of helpful because we can keep track of this in our head a little bit. So notice that if it was an empty list, it worked, right? Which is really important, right? That's a special case, and we didn't necessarily immediately work with that. If the count was 0 when we called add in order, certainly index was returning 0, and this had no problem doing that because count was 0, index was 0, 0 is not greater than 0, so we just said A0 equals value. Right, so that should work. Put in a 6. Now that should add at index 1, and we can immediately start to see whether that's making sense. Right? And that's important because we're not seeing all the, it's good to see these intermediate results. If I add a number 2, you would want that to add at index 1. If I put in 7, that should add at, if this is index 0, 1, 2, that should go to 3. If I put in 5, that should go to index 2, 0, 1, the 5 would go to 2. Right, so things are looking good. And when we print it out, we do see it coming in order. It was actually working. Right, and so we've proved that out. It's a good idea to test some of the special cases. Let's do this, and notice the special case that I'm testing here is that each number was going at the end, and certainly it is. So when I type in a very large number, it's going into the right index. If I type in a negative 5, it goes into index 0, and this is where I really want to make sure that everything's working. Let's type in a negative 1, and yeah, it correctly shifted everything down to the right. Shifted it down because I'm shifting it, printing it out on different lines. All right, well, after inserting an order, we might want to think about, well, how would we remove? How would we remove items from a list? If we wanted to remove the last item, really what we could do is just decrement count. But removing particular items in the middle of the list is a little bit more tricky. So let's just talk about the removal of items from an array for a second. So let's say I've got my array, and I've got 2, 3, 4. I'll just put them in order: 7, 8, and 9. If I want to remove the value 9, remove that from the array, realize that there's no, once you set a variable, you can't unset a variable. This is just a variable. I can't remove the number 9 from that variable. But what I can do is if I look at all these indexes, if I was to go to print this array, I would print out the whole thing, because count is equal to 7. If I wanted to remove the last value in this array, what I could do is just say count minus minus. And if I did count minus minus, it's not that the number 9 would go away, but the next time I printed, I'd only print down to 5. I'd only print over to 5. So I'd print out 2, 3, 4, 5, 7, 8. And so in theory, there is no such thing as removing something from an array. Really what you're doing is you're decrementing the count. So you're dealing with, or you're considering the array to have less numbers. Now that's a simple example because I'm deleting, in fact, the last value. So the 9 is the very value that is being ignored now from now on, since count is 6. But that's not always the case. So if we start with another array, and I'll do this a little bit neater since we're going to be stuck with it for longer. We're not always going to be deleting the last value in that array. And during those circumstances, things are a little bit more complicated, similar to the insertion. So if we look at that, we would have, let's say, 2 or 3, 8, 9, 11, 13, and 19. Okay, so we've got a count set at 6. Now removing, just simply decrementing count would remove the 19. But let's say I want to remove the number 9. Right? I want to remove the number 9 out of this list. Now, if there's no way of just changing or removing this value. What I really need to do is I need to shift everything. I need to shift the 11 over, the 13 over, the 19 over, and then decrement count so I no longer look at that second 19. Now the order that I went to is important. Of course, I'm going left to right instead of right to left as I did with insertion. If I did this one first and I moved the 19, it would overwrite the 13. So because I'm removing 9, I want to overwrite the 9 first. Let's just switch this up a little bit. If I am removing index 2, so index to remove is equal to the value 2, I would say A at 2 equals A at 3. Move the 11. I've overwritten 9 now, but 11's there twice. Then I would say A3 equals A4. Now the 11's not twice. 13 overrode it, but 13's twice. A4 equals A5. 19. And at that point, there's two 19s, but I would stop because I'm not going to say A5 equals A6 because A6 has garbage in it. So I'm going to leave it there. That's my loop, essentially. Now the next step then would be to just say count minus minus. Right? And now, when this goes down to 5, the last 19 will still be there, but the next time I print this array out, I'm only going to print out this portion of the list. 3, 8, 11, 13, 19. All right, so just like with insertion, we want to take this sort of unrolled loop and try to generalize it. Well, what's this value? That value happened to be count minus 1. Okay, so what we can do is we can say for, if we key on the right hand side first, 3, so int I equals index plus 1, while I is less than count. I plus plus. So we're scanning across to going left to right now. and we're going to say ai minus 1, remember, because I is on this right-hand side, and I could have chose to do it the other way too. That would have been fine. Either way will work, but I would just have to mess around with my indexes just a little bit. Equals ai. I go around that loop and do that, and then at the end count minus minus. So let's turn that into code and just augment program example 32 just a bit. So at the end of printing out in order, what I like to do, and in fact I'm going to turn this print statement into a function because I'm going to call it a couple more times. Let's do void print array. We've already written this function, but I'll write it again. I could, of course, because it's a function, I could probably just go copy it from the last example and paste it into here. It's easy enough, though. So I'll keep print array here, but I'm also going to now start asking the user to remove. I have to put my parameters in. Count. What I'm also going to do is ask the user for indexes to remove. So I'm going to let them type in values until they type in -1. I'm going to enter a index to remove. I'm going to do a cin input. If input is not equal to -1, and actually I should consider a couple of more things. Like I probably want to make sure that input is not negative, that it's not greater than the count. So you can kind of you can work with this if statement to make sure the user's not asking you to remove sort of a non-valid index, because this really is an index now. But I'll just leave it as it is for now, and I'll say remove from this array with this count, this input, this index, right? That particular index, and then I'll print again. Each time I'll print the array so the user can see what's happened. And in fact, I'm going to change this a bit so it prints out I, and so I can see the indexes right there. I will be the index. So let's implement remove. It'll be a void. It's not doing anything particular. Certainly it's got int a. That's certainly not constant. Remove decrements count. So I'm going to make that an ampersand for pass by reference. It probably doesn't make sense to call it input here. We'll call it index. So now we'll go down and we'll create that remove function. And again, if we look at our algorithm, index is being given to us for int I equals index plus 1. While I is, and let's go see what we wrote, while I is less than count, I plus plus. And we're going to say ai minus 1 is equal to ai. And then at the end, count minus minus. So each time we call remove, we'll print out the array, and hopefully we should see things being correctly removed. So I'll type in a bunch of numbers here. All right, here's our values. So 0 is 1, index 1 is 2, index 2 holds 4, and on and on. Let's remove index 5. So if I remove index 5, I should have seen the 7 disappear, and that's what I saw. If I remove index 1, I can see that index 1, which was 2, is now 4. Everything shifted up. I should test some special cases, like maybe testing whether I could remove at index 0. Right, that works. This one is in particular I'd want to make sure works. You know, the art of testing is testing the ones that don't look like the others. Well, removing the very last one, will that work without causing any issues? Yes, good. Maybe look as to why. If we remove the value at count, right, at count minus 1. So if we move the fifth element and count was 6, of course, then index plus 1, or I'm sorry, if this was 5, index plus 1 will not be less than count, and we'll just do count minus minus. And that's why that worked without any problem. Okay, so we've completed this program. We've completed example 32. We've been able to insert into an array in order, and we've been able to remove an array, remove elements from an array without disrupting the rest of the order. So this is a great example of really doing a lot of array manipulation, and a good one to make sure that you understand on your own. So for lab 10, this doesn't require you to insert in order necessarily, or actually it just doesn't require you to insert in order like some of the topics of the sorting module, but it is asking you to deal with arrays. So what I'd like you to do is have the users enter in a series of numbers and let them stop with -1, just like we've done before. And I want you to process each array and basically display it as a visualization. And the visualization is kind of rudimentary. Next to each index, rather than printing out the value stored at that index, so you just insert this in whatever order they add it. Instead of printing out the number 5, printing out the number 2, I want you to print out that number of stars. So it's almost like a horizontal bar graph. I want to point out, think back to lab 9. There's a little bit of a connection between these labs now. We wrote, or I had you write, a function called print characters that printed a set number of characters on one line. You really should be using this for this lab, and this lab actually becomes a fairly easy and straightforward exercise.